Let's have our read session start with deploying a model to a mobile and going up to training models across multiple devices, but not including that, just before that. So that will be about 8 pages or so, 16 pages. That's a bit of reading, right?
Yeah. So starting with the mobile devices section and going up to, let's see, which is the one, I'm sorry, which is the one we were going to stop at?
Yeah, that's a bit ambitious, right?
Well, let's try it and see what happens, right?
Okay, let's try to get onto that before training models across multiple devices.
Got it. Okay.
Yeah, that will be from page 685 up to 701. And let's get back in 50 minutes, probably at, that would be what? 1 p.m. Pacific time? No, 11 p.m. Pacific time, right? 11 a.m. Pacific time.
Yes.
Okay. Chat. Yeah, Joseph, are you typing up the sections on the chat room or somewhere?
Yes, I'll just enter
Okay.
that in the chat right now.
Okay, I won't do that. Hello? Can you hear me?
Yes, we can hear you.
Okay. Let's continue here. Somebody was able to finish until the section we said.
Yeah, it was all right.
Yeah, I was not able because I had some issue trying to set up the virtual machine that Jero was talking about, and I had the issue with the GPUs allowed by the Google Cloud, but we will talk like later. Okay, so let's continue here. Okay, deploying a model to mobile or embedded device. So TensorFlow has a library, TensorFlow Lite. We have some tools for this, and this helps make it easier to deploy the models to mobile devices or lightweight devices. And these tools provide several benefits, like reducing the model size and reduce the computation on the device. So this helps to keep the device to getting hot and drain the battery, or being slow. Okay, so this helps to adapt your model to your device, right? And yeah, there's a video code here on how to use these libraries. And you create a new model file with a different format that should be smaller and simpler. And it optimizes the model in the way that it simplifies it. It prunes operations that are maybe not needed for the prediction. For example, and also try to compact or optimize some. For example, in this way is several multiplications. It adds first and then multiply, right? So it will be a simpler operation. And also it can use a smaller number from, for example, 32 bits to 16 bits, right? That will use less memory and less computation. So prediction should be faster, right? And use your less memory on the GPU. Okay. And see. So this is a use of quantization, where you have floating numbers, and then you map into integer numbers, right? And so this simplifies the training and the prediction. Okay, here in this image we have a symmetrical quantization. 0.0 maps to integer 0, and then in this case the integer is I think it's one byte probably because of the range. So it goes from minus 127 to plus 127. Okay. And in this case, the range of the values goes from minus of the floating values goes to minus 1.5 to positive 0.8. So these values on the right will not be used, right? So it only maps to the starting from the center onto the value that is farthest, right? Okay, so this is these values, these ranges, we can say it's pruned, right? It's omitted, it's not used. And then there are like commands to make this optimization to take place. Okay, and this reduce the model size, and it's easier to faster to download and use spare some space in the device. And then I'm saying that this can be done entirely with integers. You lose some precision, but you make this easier, faster, and more lightweight. Right? Okay. And he's saying here that for actually deploying, he's not trying to show how to do it because he says it's a lot of work, and he's recommending a book for this. Right? TinyML. Okay, and so there is yeah, to show the difference, for example, between a model and the TensorFlow Lite model, there is a website that he recommends. Let me see it here. Yeah, it's here. Yeah, this is a model from this paper. Okay. And this is the original model. You can see it's this is the size of the original model, and if we see closer to a quarter of it's like this, right, of the model. So we can see the structure. And once we simplify with TensorFlow Lite, we get this model. It is much simpler, right? So it is not as precise as the original, but is precise enough to use in mobile applications. Okay, so that's about the mobile deployment. Okay.
Yep. Just to can you go back to that page?
To the original or the other one?
Yeah, I just had a query about the paths that these models are taking. So here the paths, if you zoom it out here, yes, here, it's a straight uh, uh, stack. So I was thinking between this and this is for the TF Lite, right?
Yes, this is the ATF Lite.
Yeah, this is the TF Lite, and the other one was for the
The
model
original
that we
PV.
created. Yeah. So I was
Yes.
thinking about the various pathways that this model, the full model, is taking. Uh, how does this convert to that? Because here we have the depth-wise convolutions and on to 2Ds. And how is it uh, then those addition operations which are uh, taking in the information for from two channels here. Let me try to annotate. So from one channel, this, one channel is this, and here it's adding this guy. So if this is a simple multiplication, uh, this is a con 2D, then this is a depth-wise. So uh, I was just thinking, how does this compare to the pathway that that the applied model takes?
Maybe we put it like side by side.
Yeah, if
Let's see that.
we can. Yeah.
Okay.
I said this is the overview of the con 2D and the depth-wise 2D depth-wise con 2D. And if we can show the other way, because here we are seeing the element-wise addition and multiplication too. But if we just see the con 2D and the depth-wise con 2D, and the other layers on the left, on the left side hand side of the figure, yeah. If you can just zoom out on this. And so is there a way to convert this in this form and on the left hand side figure to the right hand side form?
Yes, yes. That's why Jerome is talking here. It's they use this library call
Uh-huh.
to convert the file.
Uh-huh.
Okay.
Ah, okay, okay.
Uh,
So no, so here these operations are these matrices. If we the matrix here is addition and multiplication operations. And on the left, the diagram that we see, and coupled with the convolution layers. Can we have this in can we remove this multiplication and addition operations on the left here by some option here? Let me try to annotate these operations. Can we remove them all and just be and if we had only these operations, this one, this one, this one, so we can have an apples to apples comparison between how this one stacks up versus this stacks up. So if you can understand my
yeah, I know what you mean, but I know it's taking a lot away, right, from the original model.
mm-hmm.
But yeah, this is there is a paper here that
Yeah,
is
this is
yeah,
mm-hmm.
is talking about this. But I'm not sure if the model on the right is going to be good enough, but they say so.
Mm. Or for the right model, can we see the number of addition and the multiplication of operations that are being performed?
Yeah,
Uh,
that's it.
can you
There is no
write?
more. There is no
Yeah,
more. Yeah.
yeah. Okay, there might be some other options. Okay, then that's fine. I think please right click here and then yeah. Because yeah, this will give in the node properties, the inputs and the outputs, and uh, the left. Could you go on the left hand side of the figure? The left figure, yeah. And here you can try right clicking on the
On this one.
yeah, suppose. Okay. Left clicking and then they will okay. No properties. And what will the addition and multiplication node properties represent? You try clicking on the mult add or the sub node. Yeah. Okay. I haven't seen this detailed view. I've seen the view from the right hand side. I've tried it with in substitution blocks too, but yeah, this detailed view with respect to each of the number of multiplications and the subtractions. So I was a bit curious. Okay, then, thanks. I will
Yeah.
explore it deeply. Thanks.
Yeah.
Please.
Yeah. What I see is that the files are like the original is 4 times larger than the TensorFlow Lite file. For example, this is the original, is 2 megabytes, and the TensorFlow Lite is it's like half a megabyte.
Yep. Yep. I think so. Those operations are also abstracted away in some way. Yeah. When they are converting the normal quantized to the frozen one, the PB one. And those abstractions cannot be seen by this uh, neutron app here. So this might be the case too.
Yeah, also it would be interesting to see the differences on precision in the prediction from the original and the light model, right?
Yeah, cool. Thanks.
Yeah. Okay. Yeah. Yeah. Any other input on these models from anybody? Okay. Let's continue. So that's so far what Jerome was saying about the mobiles. Then he talking about the doing the TensorFlow in the browser. So for this, he the TensorFlow JavaScript library is used, and it has some benefits. For example, you have somebody connected very far away or remotely, or with a slow, intermittent, or bad connection to internet. And when you want to have responses to the prediction very quick, you don't need to wait for the server to give you the prediction, but you can predict and use the model in the client of the user. You don't need to wait for that. And also, this is interesting for me, at least, because you can, in some way, guarantee that your private data information is not going through the internet and is not stored in any server, right? Okay, so there is also some example here on the code to use the TensorFlow JavaScript library. Okay. You have to import the library and then define the model type and how to use the prediction, right? And it doesn't go more far away than that. He's recommending another book for this whole subject, right? Yeah, and that's it about the mobile and web prediction. Anybody has used this TensorFlow in the browser? No? Okay.
Yep. I have used it. I tried on a couple of examples too. Yeah, it's kind of cool. And yeah, I will share a library that uses TensorFlow and this. That's a media pipe. If anybody might have experimented with that too. They also use um, uh, TensorFlow uh, under the hood. MediaPipe is uh, uh, how do I say it? Uh, library for the representation of live ML across platforms. So uh, here I've shared a link in the chat. It's across the Android, iOS, C++, Python, and the JavaScript ecosystem. So if you can open this link, yeah, it has a quick uh, solution from the perspective of face detection, face mesh, iris, hands, pose. Uh, yeah. So, if you can scroll down, yeah. So this is the out of the box. Uh,
Oh, that's interesting. And this is on
mhm.
several platforms, right?
Yes. Yes.
JavaScript also. Okay.
And you can just run it on the web too, directly.
Okay. Okay. Oh, that's great.
And it's by Google, so they totally maintain it. And yeah, there is also how do I say it, Slack channel for it, and you can ask your queries, and yeah, there's a complete ecosystem around this media platform.
Okay. 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 Thank you, Yang.
Yep.
Okay. Let's continue because this is a big subject, right? But okay, let's go back to using GPUs to speed up computations. Okay. And okay, so as everyone knows now that training on CPU can take many times more than on GPU, right? So we always aim to get the handle of GPUs for the work, and here we see that TensorFlow can distribute a load between GPUs and CPUs and GPUs. Okay. Yeah, this is very interesting. He's saying that if you have four GPUs in a machine, it can be as fast for training as having 8 CPUs. That's double across several machines. So if you can pack your GPUs in a single machine or server, it will be faster than having several machines, even if they have more CPUs. Right? That's because of the network, the transfer speeds. And also, it recommends going for a powerful CPU instead of several slower GPUs. Somebody was saying somewhere else that it can be better sometimes if you're going to test several models that are not resource intensive to have several slower GPUs to train separately at the same time. But there are ways I saw later, we can see later that you can like train different models in the same GPU, right, with TensorFlow, and keep the resources separate. Now, TensorFlow is using, let me see, how do I? Start seeing this. Okay. Okay. He's giving the link to this Tim Detner's blog that I have seen before. It has a lot of information of GPUs, performance, and building your own machine for this link. Right. But this keeps being updated because new GPUs come, and some time ago I was looking at a way to get build a workstation with a couple of GPUs, but I think beyond that, like 3 or 4 GPUs, it was like more problematic. I don't know if somebody has some comment on that, having like 4 GPUs in a single machine for your own at your own site. Okay, so but Google provides the TPUs, right? Usually more powerful than the GPUs, but only Google's have them at the moment. We can work so with both TPU and GPU cards for TensorFlow. But anyway, TensorFlow is going to use the CUDA and the CUDA DNN libraries to reach the GPUs. So we need to get those in place, installed and working before using TensorFlow. TensorFlow will also be using talking with CPUs for some tasks. So here's the NVIDIA SMI command to check with CUDA how is the GPU being used. We can see the the memory usage and the processing. Right. In this case, is nothing is running here, and from this it seems nothing has been run yet, recently. No, nothing is used yet. Also, when using the TensorFlow with GPUs, there is a different distribution. So it's a different library that you have installed. And he's saying that Google is working on a single installation for both CPU and GPU. Anyone knows if that is already available, or we still need different installations? Okay, also we can use a Docker image provided by TensorFlow with everything in place already. but I will still use the NVIDIA drivers for the GPUs. Okay, we have some lines of code that we can see in the notebook. Okay. And then using a virtual machine with a GPU. Okay. Yeah, we can go to the, let's go to the, he's showing, providing the link to start a virtual machine with GPUs. I had trouble doing that because I was trying to get GPUs and it was working for me, but for only one CPU. So I requested to get enabled more than one GPU, but I got rejected. I got that. Yeah, no, this is not one. This guy. Yeah, I have to wait like 48 hours to try again, or wait until my billing account has more history. Right? So far, my billing account has about $6. So no good for them, I think.
So you have exhausted the 300 initial dollars that you
Yes,
get
yes.
when
Yeah, I like 1 year ago, I think I was using the free $300, but they are really gone.
okay.
And yeah, and some couple of weeks back, I put my billing in place. Now it's charging me. It's not much, but it has no history, right, for them. So I was not able to increase my quota of one GPU to two GPUs. So let me see on the left side. Okay, lost it. Quota. Let's see, I get it. Yeah, it's here. So I got the virtual machine, but when trying to increase the GPU from 2 to 1, it was not working. So that's the message I get, right? I was following the instructions from Jerome on the book to increase the quotas, but I was not finding that. I found the link from other places, and then I was here, right? I found this with this service ID. I found these two messages, and I requested both. With both were denied so far. So I cannot get two GPUs yet. Okay. So let's
okay,
back to
that's fine. We can create a virtual split, on the GPUs too.
okay. Yeah, even if it's one, right?
Yeah.
Okay. Okay, so we got to the notebook here. Okay.
Yeah, I think you have stopped sharing your screen, so
Okay. Yeah, I see that. Let me show again. Let me know when you can see again. Yeah. Can you see my screen?
Yep.
Okay, thank you. Okay, so let's get back to the section for GPUs. So the libraries to show what GPUs do you have from TensorFlow. Here you can see I have only one GPU. Right? And if we have more than one, we will see the list here. And we can get device name here also. We should get a list, right? But there's only one here in this case. And to check we have CUDA in place, it is. I'm running this from Colab, by the way. And yeah, it doesn't make sense for me to try to run it in the virtual machine Jupyter Lab because I only have one GPU there also. So it will be the same output. Okay. So to list the devices, it's only one here. And we'll see the memory and see the device number and the model. So that's a lot of information. And then this, I was not able to test yet. Let's run this. Okay, see it, and create the model. And run the training. Okay, X-train not defined. Okay, I need to run the others, right? Okay. Here maybe X-train. Would that be enough? Yeah, maybe. Okay, yeah, it's different training, right? Let's this finish. Okay, here, here in the right is the from the book, the instructions from Jerome to create a virtual machine for testing. You have to make sure that it has TensorFlow, and these are two checkboxes in the creation of the virtual machine, and then enable the Jupyter Lab. Okay. That's one way. The other way is with Colab. Okay, this is the how to enable the GPU. It's already in place here. One time. Right? It's already there. Okay. And then Colab has some restrictions, like five simultaneous notebooks running. And they also, if they're not attended, it can be closed in under 30 minutes. It has happened to me often. And then you can only run like 12 hours, right? Continuously. You have to probably save and then start again from where you stopped. Okay. Okay. Then you can manage the GPU RAM. You need to, for example, running several trainings at the same time. Okay. You can set up these environment variables and run the different programs. On this example has 4 GPUs, and 2 are reserved here for one program and 2 for the other. This is like separate by devices, right? And then you can also separate by RAM, right? In this case, you for each program you assign certain amount of RAM, a memory limit for each of the GPUs. And then once this is trained, you can see the usage of the NVIDIA of the GPU's memory. And let's go to the next notebook. Okay, let's see now. This one. Does this work? Okay, I have to wait, right? I have a console here. Somebody knows how to open a console here in Colab? Okay, there he is. Yeah, but this was after the previous training was complete. So
I think at the bottom left, there's a little black square on the left column.
Okay,
I think that opens the column. Yeah.
Okay.
Or at least it opens a shell.
It needs Colab Pro. I think I did that before. Yes, it is. I really subscribe to Colab Pro. Yeah. Do I need to reload these?
Have you subscribed?
Yeah, I did. I did during our reading session. I subscribed to Colab Pro.
You can reload, right? That will reload.
Okay.
But it should. I don't think so. Reload.
Let me just bigger reload of this guy. The page. Yeah, let's reload the page. I need to run this setup. Let me see if it's working. Yeah, it's working now. Yeah. Okay, so I need to in the beginning. In the meantime, see. Not yet, right? No. Do I need to do something here before it works? Make this white. Okay. Okay, extra is there. GPU. Okay. It's not. Oh, yeah. I missed to change the runtime to GPU. Now it should be here. Yeah, it is there. Full screen. Okay. So we have a Tesla V100 and 16 gigabytes. No usage yet. Let's run here. Also, you cannot get like 2 GPUs in collab, right? You're limited to only one. Is that correct? I was looking for some way, but I did not find.
Yes, as far as I know, I can only get one. I do not know about the Pro features, the benefits that they offer, but yeah.
Yeah. Okay, we now get a device, a GPU. It has CUDA, yes. Okay, and then list of devices, it's only one. B100 here also. And limit should be the same information, right? Okay, and then create the model and train it. Can root that. We can now check.
Now we can have that NVIDIA-SMI/L equals 1.
Like that. Dash.
L space 1. Sorry.
Okay.
Yeah.
It's continue updates continue, right?
Yeah. You can.
But
just to stop, yeah. You can scroll it up a bit, and it will. Okay. You can also press Ctrl+C, but yeah.
Yeah, I see.
It hasn't increased here. It's the same.
Okay, let's go up. In the beginning. Here it is showing
a wattage increase.
Yeah, more wattage, but I don't see processes here. Right.
The PID and the process here.
Let's try to do this again. And I was expecting to see a process here in this section.
There might be some disconnect between, because this is running on the GPU. We checked it earlier with the TF dot use GPU.
Yeah. For example, this is on 37 watts usage, around that. Keeps there. But once this training is fired, the wattage increase. Yeah. So it's being used. Right.
Yep.
But I don't see the process here being identified.
And even the memory is the same, 1309.
Yeah, and here's the utilization. Yeah. Yeah, 60% utilization. Now should be gone. Yeah, 0% and only 38 watts. Okay. Yeah, it's not showing the processes, but it's indeed being used, right?
Yeah, it is indeed being used.
Okay. And then this is to distribute. Okay. Okay. So this is this cell is for multiple GPUs, right?
Yep. It acts as a master slave cluster. So yeah, that's the clustering technique that is it's being used with respect to distributed or hierarchical.
Okay. But I only have one GPU, so you cannot test this
Yeah.
really.
We can have a how do I say it? A virtual GPU. We can create one, and then we can apply this strategy to replicate those scenarios. That can work.
You mean the yeah, I saw the some virtual GPU comments on the book, right?
Yes, yes, yes.
Okay, you can specify which one. Okay, yeah, and the CPU is always one device, even if you have multiple cores.
Hmm.
Yeah,
Yeah,
yeah, but
Yeah, multi-threaded kernel here can be used as a data pre-processing step in which, yeah, we have suppose argumentations and other stuff that needs to be applied. That prefetch and all that we have studied in chapter 12 or chapter 13. Yeah. But, from the practical standpoint, in designing the pipelines, multi CPUs, if we have a server that has uh, physically two CPUs installed, then I don't think so. That is functional. I will have to delve deep into that APIs, but I don't think so. That is supported because I haven't currently seen that.
okay.
Multi GPU support is there, but multi CPU, there must be some somewhere. I don't think so. They might have totally ignored it, but yeah.
Yeah, maybe TensorFlow is considered every CPU as one bunch, right? And CPU
Hmm.
series everything CPU under there.
Yeah, might, yeah, that might be the case.
Okay, so about the parallel execution across multiple GPUs, right? So TensorFlow keeps a dependency information on the operations, and then put the dependency numbers. So, for example, this operation F depends on all these below being completed before running. So it keeps like, let's say, a 4 until one of these completes, then the dependency number decreases, and when it's 0, then it runs, right? So, for example, these A and B go here on the CPU, and they run they run sequentially, each one of them, and then when one is multi-threaded, it can be run multi-threaded, and when both are complete, then when each one is complete, F is decreased in the dependency number, right? Here on the right side, they go to the GPU, right? On the GPU, they're sequential, but the actual task is very parallel. So there is no problem, right? No problem that they are doing in sequentially. Okay. Yeah. Yeah. Operations on the GPUs are sequentially, right? But they are actually massively parallel once they are running. And he was saying that the GPU is actually mostly of the time busy, so there is no concern of the operation being serialized. Right. And yeah, I think we talk about this, right? We can train several models in parallel, one in each CPU. Okay. And we can do the preprocessing in the CPU while we train a model on the GPU. And then, for example, he's talking about two CNNs that are going to be joining the output, so they can run in parallel on different GPU to optimize the execution time. Okay. Okay, training models across multiple devices. I had no time to read that section. Anybody has any comments? This?
I had a bit of an intuition here with respect to what happens uh, uh, since it is displaying some sort of a data parallelism. So you can think of at as each part of a GPU. Sorry, if we have 4 or 5 GPUs, then those 4 or 5 GPUs will have some part of the original data that will be divided into those halves. And uh, and those models intuitively might be split into those 4 or 5 halves. And once those uh, training across those 4 or 5 halves are uh, complete, then we can join it and uh, kind of have some sort of a cross-device communication to uh, uh, to make our model uh, uh, give predictions with respect to the correct distribution shifts that are actually required. Uh, uh, that that we get. So, from a high level point of view, that's the thing that we do. But if we dive into the details, the problems that we will face might be with respect to the latent space distribution shifts, in which the mini batch parallelization across a data set, and since those data sets have been divided into 3 or 4 parts, and how will that be combined to form a complete holistic path in which the anchors of a suppose classification model is being put into the right place. So that's my whole data and model parallelism intuition. I think.
Yeah, thank you, Mayank. Thank you, Mayank. I was just noticed that we were not planning to read this today, as we talked earlier. So maybe we can start next session with this section. And before that, before closing today's session, does anyone have any idea if I will be lucky in getting my GPU increase approved on the Google Cloud by next session?
Yep, I think so. They will be able to.
Yeah. They say for me to wait 48 hours or get or wait for my history, my billing history to increase. But I would try. I would try probably on Tuesday morning to see if I can create. If not, I would try to follow that virtual GPUs setup. So we can probably simulate running here, or get some other service to run multiple GPUs.
It's fine though. But since we have already looked at the mirroring strategies and how will it work, and intuitively, I think so. We understand how those chunks across the different GPUs should work.
Okay.
So if it doesn't, then I think so. It will 90% plus probability of the guys from Google will give you access. But yeah, if it doesn't, maybe we can take a look at that in the next session too.
Okay. So I think it's time to close for today.
I just had a quick query with respect to TensorFlow.js, and if anybody has used it across the web or cross-platform. I saw Nitin's comment. So
Yeah, sorry. So I have some experience with TensorFlow JS. They have a React Native binding. So with that, you can do cross-platform with like Expo or like the whole React Native ecosystem. But the thing is, it doesn't look, I mean, I got something working, but it doesn't look like it gets as much support as TF Lite.
Yep, I agree with respect to if we go in from the TensorFlow.js perspective. So in the backend, you might be using some sort of NVIDIA's GPU abstraction to parallelize or compute, or for the compute from the TensorFlow.js perspective, or you used OpenGL's APIs?
So I've only done it for inference, but I think it's like what you mentioned, that TensorFlow JS supports multiple backends, and for the web, it's WebGL, and for React, I think it's some binding on OpenGL that is in the React Native ecosystem.
Okay. Thanks. Yep, thanks. So we can close this session. If anybody else has any queries.
Okay, well, thank you very much.
Yep, thanks, Alvaro. This was quite good. I missed the last one, but yeah, this intrigued my imagination. So thanks for this.
Yeah, thanks, Alvaro.
Yeah.
Thanks,
Thank you, guys.
Alvaro. See you guys Wednesday.